All right, so I think Clancy had told me that this assignment was too easy.
I don't think we talked.
When we asked Clancy for help, he walked in and said, "This is impossible."
I didn't say it was impossible. I said it was. So.
Was that a quote?
Direct quote.
All right,
I said I'm crying right now.
so let's put some stuff into perspective. Remember way back when we were in 200 and again in 250, we spent some time looking at documentation and things like that, right? And one of the things I told you was a important skill set you need as a programmer is to be able to understand documentation. Remember all those times we said, what's the difference between a static method and a non-static method? At the time of definition, at the time of calling it. So reading the documentation tells us how we can call things. So being able to read documentation and look things up, tells us how we can use certain things. Now, last class I introduced a library called string, right? The string library. And I just went to the site real quick and showed you a couple of string functions and things like that are built in there. Now, let's say you're doing some project at your house, and you go and go to Home Depot. Well, you kind of think about, you're going to build a shed or something like that. And you think about the, kind of how you might go about it, hand draw a couple of the designs, things like that. You head over to Home Depot, or maybe, where do you work? You work? Ace. A better Home Depot? Correct. Okay, so you go over to Ace, and you're shopping around, looking at some of their different tools, and you might find like some tools that look weird. You're not really sure what they do, but you figure you could probably learn how to use these with a little bit of instruction, whether you look at the documentation for it or something like that. But any way you cut it, if you buy some stuff, you bring it home, you're ready to solve this problem, you need to understand the tools you're going to be using, right? You don't just start building the shed with tools you don't really understand and expect to have a very good shed when you're done. Does that sound accurate? Okay. Now, how many of you, I already know the answer of this based on anybody who asks questions, jumped into the deep end of this assignment without really experimenting with the tools that you had available? Truly understanding the tools, understanding arrays, understanding strings, what are the limitations, how do I think about the size of things, okay? So let's experiment with this for just a few minutes. I mean, we're just going to take like 5 or 10 minutes and mess with some of the things that we think we're going to need to solve this problem and make sure we can wrap our mind around how they work, okay? Because really we're kind of time travelers here, right? If you think back to the first week of class when we wrote we had that paper that talked about kind of old school C++ and then new world C++, how it's evolved. Do you think that C++ has kind of introduced some tools more recently that has allowed us to solve problems more like maybe we think about things in terms of Java? Probably. Now, what are those tools though? Like that string, it's actually a namespace, but whatever. So the string namespace, that guy, is it something that we couldn't have written ourselves? Or could we probably write that? It just has a bunch of stuff built into it that makes our lives easier and maybe is things that modern day programmers have kind of decided most languages should have these things built in. All right, so you could take either approach. You can say, I'm going to use the built-in strings that have modernized C++, or I'm going to stick with old school. But let's kind of look at both of these and make some decisions. All right, so I went and I created 2 strings here. So we want to think about 2 different things. Well, really 3 things. We want to think about the different ways we can represent strings, and then we also want to think about arrays. Because one thing I mentioned, and you've seen it if I have something like int argc, char pointer argv. That's the kind of the go-to main method for C and C++ programs. What is argc? What does that guy stand for? Or what's this whole thing used for? What are the parameters that come into main? What does that support? Go ahead. Command line arguments, things we might send this guy from the command line. All right, so if you remember from Java, this guy would have just taken a single string array arg, something like that, right? So we only took 1 parameter in Java, where in here we're taking 2 parameters. All right, why do I need two parameters? What's this first parameter mean? Go ahead.
The amount of
Argument count. Argc is argument count. Okay, this is not the first time you've heard me mention that in this class, right? All right, just kind of in one ear, out the other side, Brocker.
Sure.
All right, so this is the argument count. What's this guy? What's a char pointer pointer? What kind of animal is a char pointer pointer? A string what? Well, that's a string. A char pointer is a string that points to the beginning of some memory where the first character of a string lives, and then everything is an offset off of that. So what is a char pointer? Pointer.
String array.
String array, just like we have in Java. So Java has a string array, and in Java, arrays are able to report for us their length, right? In C++, they don't as conveniently report their length, even though we do have in standard library now an array class that is more of an object-based array class that does allow it to report its length. But we're gonna do a little bit of old school and a little bit of new school today, but we're gonna experiment with both leading up to it. But we're going to try to base, so this guy is a string array. That's what that is. Sometimes you'll see this written as a char pointer argv like that. That's an array of char pointers, where a char pointer is a string. Make sense? You could also technically write this as that. You should be able to write it as that. Oh, maybe if you're going to use 2, you do have to give it sizes. All right, but cool kids would write it like that. Char pointer pointer argv. Okay. Now, we're not taking in command line arguments, so we've chosen to optionally not take in anything there. I just wanted to throw that back up there to remind us of 2 things. First thing is that the traditional thought is that in old school C, where that main method came from, right, with the argc and the char pointer pointer argv, arrays were not able to report their length. All right? Now, let's start with this integer array here. If I want to go through and I want to fill up this integer array with a bunch of numbers, so for int I is equal to 0, I is less than something, I plus plus. I want to go through every element of that integer array, and I want to fill up the array. So AR at bucket I is equal to I something. I'm just going to put numbers in it. What do I put here? How many elements are in AR? Well, there's 20, so I could hard code it 20. But whenever we're hard coding literals, we're probably doing it wrong, right? Well, so then what do I put here? My thing is called AR. What's the length of AR? Go ahead. Okay, so we want to experiment with that. So I'm going to say cout size of AR. And you've seen this before from me for actually several years as we've talked about how arrays work in contiguous memory and how we can calculate from the base address to an offset. Bucket 3 is 3 times the size of whatever the value that we're storing is. All right. What do you predict this will print out? Go ahead. Okay. Yeah. So tell me what's your guess then? What is this going to print out exactly in this case? What's the exact number it's going to print out?
8.
I'll give you the hint I was going to give you is you're right. Okay. So you're saying this is going to print out 80. All right. So let's see that. So there's our 80 right there. So the question is why did it print out 80? I created an array capable of holding 20 of these guys. How big is an int? It's 32 bits or 4 bytes. 4 times 20 is 80. So how many elements, how do I calculate the number of elements that are in this array? Go ahead.
You're going to have to divide it by the
Size of int. That will give me the number of buckets in that array. There's my 20. You could have done size of char.
Yeah, but it wasn't working.
So we'll create a char array of size 20. We'll go ahead and print out the size of that array. What's the size of that array going to be? Phone a friend. Okay, pick a friend.
No.
What a friend.
I don't think that's how the game works. Is this, who wants to be a millionaire? I don't think you can call up Grandpa and then Grandpa says, "Well, let me ask your grandmother." Although they probably will allow that.
What is 160?
What is 160?
That's Jeopardy, man.
Okay, so you're telling me that you think a char type is 8 bytes?
That's wrong, isn't it?
Isn't it a byte?
It's a byte.
Oh, told you. Thanks, no.
There's 20. A char is 1 byte. Why is a char 1 byte?
It's just one letter.
Okay, well, why is only 1 letter 1 byte? What are chars in Java? How big are chars in Java? All of you know this, because I assume you memorize every word that comes out of my mouth. A char in Java is an unsigned 16-bit value. In C++, it's an 8-bit value. Why? ASCII versus Unicode. All right, so ASCII is actually a 7-bit value, but the smallest data type we have in C-style languages is a byte, which is 8 bits. So we're actually not fully using that space. Okay, but the size of a char in C and C++ is 1 byte. But we don't need to worry about that. We can say divided by size of whatever that guy is. That will boil down to the size of a char. We don't have to have memorized that it's size 1 or 2 or Brocker's I support alien languages, 8 bytes, 8, whatever. It's the next generation Unicode. Brocker code supports languages across the universe. Did you know that grains of sand can speak? Killing me, Brocker. Well, not as bad as Clancy, but it's bad.
That's a good
What would you say?
No, just
playing this game.
Yeah,
The
there's
character's supposed to have a mental breakdown.
Yeah.
You're supposed to have that right now.
Oh.
There's this
Just
game
joking,
called RimWorld where you like manage a sci-fi colony and it gives you alerts when they're like stressed out and it's like they're at a minor break and I think with all these comments I'm about to have a minor.
Oh, well, that's good.
Yeah.
Because this is how learning occurs. Every single time you come to class.
Every time you torment in class, you learn.
That's the point. I mean, think about it. I mean, I saw a group last night working. I saw the Noah Brocker group. They were across the hall here when I came in to teach my grad class, and they were working over there and asked me some questions. As a teacher, that's what I want to see. And I want to see you suffering. Okay? But not just unnecessarily suffering. I mean, you guys, restarted your project 2-3 times, something like that? Because you kept running into things that didn't work. But how much did you learn during that? There's a reason why, as we get into later and later classes, I hand you less stuff to start with. Does that make sense? Because I know it sucks that you have to set aside 8 hours to work on your stupid assignment. Okay? But I promise you'll come back and thank me later on when you're making $150,000 a year in Midwest dollars, writing software, not even having to put pants on. right? These are the skills you have to build up in order to do that, and you're not going to get that. We already just proved that you're not memorizing every word that comes out of my mouth, right? You know, these are things you've heard me repeat over and over and over and over and over again, yet it's still not sinking in because it only sinks in if you did it yourself. You go through and you have that experience and, you know, well, this didn't work, this didn't work, this didn't work, this didn't work, and you find that the last thing you try works. You know what? You figured out 4 things that didn't, or 4 things that didn't behave the way you thought they were going to behave. But do you see, like, before I've even dived into this program, I'm messing around with some of the tools I might use to make sure I understand those tools. So when I go start writing the code, I now am going to be confident in what I'm writing. All right? So does this make sense that I can have collections of things and I can ask, what's the size of something? This would not have worked in very old school C. The size of an array, because of the way contiguous memory was handed out a long time ago, it would not necessarily have known where it ended. Does that make sense? All right. What if I said size of S? Here. Here's S. S is a char pointer, right? And this guy is going to have a bunch of characters inside of it. What do you think this is going to output? Number of characters that were there, you just missed a character in your count. But you were right? You know, it's the number of characters in there. Isn't that the length of the string?
I think it's 1 more.
It is 1 more. Why is it 1 more?
Because it has to, like, the end. Like,
There's a string termination character, which I think I also mentioned in class at some point. What is the string termination character? \0. Yep. So it would be the length minus 1 would be the last, be the actual length. That's the number of characters that are in there. But we now have the ability of getting the length of a string using that style string. Okay. Similarly, what if I were to say cout s2 dot length? That looks very Java-y to us, doesn't it? There's our 8. That looks just like Java, doesn't it? So we have a class called string that is a wrapper. I promise you it's a wrapper for this, right? Its length method, what did it do? It returned the size of its char pointer minus 1. Go ahead.
Quick question. I was a little bit confused on why the string was able to use, like, the dot notation.
Mhm.
How come we can't, like, the functions we have written for, like, the classes, we weren't able to use?
Because this isn't a string pointer. This is a string.
Okay.
So
Okay.
I don't think I could actually create string pointers this way. I can't give it a literal because the value of a string pointer is a memory address.
Yeah.
I can say string s2 and then I can say string pointer s3 is equal to s2. This whole bit. Do I have to give it the address of it? I don't think that's going to give me the value that I want it to give me. And now if I say S3,
Oh, okay. Yeah, sorry.
there's my
Okay.
8. All right, so remember that arrow. So, I mean, this is a good question. This arrow here, what does it say? It says this guy is a pointer. So rather than me saying star S3 dot length like that, I guess I should have just written on another line. I can say S3 arrow length like that. These two things are equivalents. I call this syntactic sugar for this. So this arrow here is syntactic sugar for that. That make sense? So whenever you're writing the arrows or the dots, you don't want to necessarily be just guessing. Like, I wonder if I can use an arrow or if I can use a dot here. You want to think about what is the animal you're using to call. If the animal is a solid object, like in this case, my S2 is I don't have any pointer syntax there. This guy is a solid string object.
And that's called a literal, you said?
Well, this is a string literal.
Okay.
Just like int a equals 7. 7 is a literal.
Okay.
Yeah, so a hard-coded value is a literal. We didn't specifically ask for memory for this guy.
Okay.
All right, so S2, here, let me actually show you this. So string S4 is equal to this guy. Then I'll see out the address of S2. And the address of S4. All right, and we saw this in Java, because remember in Java we looked at, well, these two strings, these are two separate variables that both hold the same string. Remember we used the equal sign to determine if two strings had the same, were equal to each other? And it actually is not checking the contents of the string, it's checking the memory address of it. So the first time I wrote a string literal here, it created a place in memory for that. Actually, it would have done it on this one. So actually, if I printed out S, see out S, oh, that's interesting. That C out actually resolved S to its string contents, because S is actually a pointer, but it noticed it's a char pointer, so it treated it, C out treated it as a string. So if I just put the address of this guy before it, to say, show me the address that it holds. See all those guys. Actually, that one was, they are all different. So what does that tell us? That tells us that each time we create a string literal, so this is actually different than Java. Every time we create a string literal, it's actually creating brand new memory for this guy.
Okay.
All right, so it created a place in memory for this string. It created a place in memory for this string. It created a place in memory for this string. But now, how big is that place? So 20, 40, but this is a hexadecimal value, right?
Oh, yeah.
So this is 32. This is 64. So it's creating a 32-bit space. Why is it 32 bits? This guy is holding a 32-bit value. This guy is holding a 32-bit value. This guy is holding a 32-bit value. What if I created a string S5 and I just kind of laid on the keyboard for a while? Definitely a longer string. These were much more convenient numbers to work with. It's the same thing, but it gave me another 32. All right? So the length of this guy did not dictate how big of a value got stored in here. Why is it always 32 bits or 4 bytes? And what's the type?
String.
Nope.
Char.
Char pointer.
We're getting close.
Memory address.
Memory address. A pointer is a memory address, right? Memory addresses here are 32 bits. So anything that I create, if I look at AR, I printed out the address of that guy. So here, watch this. If I do, I should be able to just do AR. That'll give me a memory address. Oh, Interesting. It tries to resolve it as a string. So if it went to the memory address of AR and tried to figure out what is that in ASCII. But if I give it the address of that guy, that'll be another 32 down the line. All right, and why is that? It's because this variable holds a memory address. This variable holds a memory address, holds a memory address, holds a memory address, holds a memory address, holds a memory address. Memory addresses are 32 bits. Go ahead.
When I was testing at one point, my output was matrices. What does that mean?
What, it said matrices?
No, it was like a box with 4 numbers inside of it.
My guess is, were you not using these? What kind of animal were you using? Were you using like the newer style arrays?
I think
If you're, because there's a, in the standard namespace, there's a new style array that can report its length more conveniently, and that one might have like its version of toString that shows it in a different way. Like, here's the best way I can show you what I look like if I'm printing it.
How come, so you created S first, but when I was looking at the memory addresses, it wasn't before, it was,
You're at the mercy of the OS for what address it hands to you. Yeah, the operating system says here's an address, but it's 32. It's a 32-bit space to hold an address, because that guy actually is going to point to where the actual string is somewhere in memory.
well, unless it's an array, just because you created that variable first doesn't mean it sits first in memory.
That's a correct statement, because you are at the mercy of the operating system. As the programmer, we're asking the OS for memory, so we're stuck with whatever address it gives us. You know, if you moved into a neighborhood, the order in which you moved into the neighborhood doesn't necessarily mean which house you're in. You know, you might be the one on the corner lot, even though you were the last one to move in or something. Yeah.
I wrote my notes about that a couple of weeks back that a 64-bit OS uses 8-byte size pointers.
For memory addresses, if its memory allocation table is 64 bits. So when something says I'm a 32 or a 64-bit operating system, that's a generalistic term that indicates that the operating system as a whole can run 64-bit bytecode, but you're still at the mercy of how they wrote their memory manager, how they wrote their file system manager. They might decide, so for a 8-byte, well, in this case we have 4 bytes, so a 4-byte memory address would allow us to have, so this is 32 bits, so this is 2 to the 32nd power, that number of unique memory addresses in the system, if that's the size of an address. So that means if we multiply that by the size of, so even if we say each bucket of memory is 1 byte, usually it's bigger than that. But if it was 1 byte and we multiplied this, so we would say that's the number of bytes that we support in memory. So we divide that by 1024, that's the kilobytes. Divide that by 1024, that's megabytes. Divide that by 1024, that's gigabytes. So if you only use 1 byte memory, you only support 4 gigabytes of memory. But usually what they'll store at each bucket of memory, if you think of memory like an array, is something maybe like 16 bytes or 8 bytes, something like that. So you might waste some of memory, but chances are you're storing things in a bucket of memory that's larger than 1 byte. Usually 1 byte's a pretty small thing. So we can then multiply this by, we can decide with a 32-bit address space, I can support maximum amounts of memory in my computer greater than 4 gigabytes. 4 gigabytes is the minimum, right? But I can get 8, 16, 32. Most of our modern operating systems give you 64 bytes, or 64 terabytes is the, I'm sorry, 2 terabytes is the, so 2 times 1024, that's gigabytes, divided by 4, so that's 512 bytes per bucket of memory. So that kind of tells us if you're in an operating system that has a maximum addressable memory size of 2 terabytes, then you have 4.2 whatever billion buckets in memory, each one capable of holding 512 bytes. Does that make some sense? So punchline is if we went to 64 byte memory addresses, or 64-bit memory addresses, or 8-byte memory addresses, that would allow us to have 2 to the 64th. That's the number of buckets in memory we would be able to address, if we treat memory like a giant array. And if each of those buckets held 512 bytes, that's the number of total bytes. I divide that by 1024, that's kilobytes. 1024, that's megabytes. 1024, that's gigabytes. 1024, that's terabytes. So do you think we're pretty far off from having computers with that many terabytes of RAM in them? Okay, so we can make the decision that we don't need addressing space bigger than 32 bits right now, or 8 bytes, because that scalar, what it gains us, is something that we don't currently need to use. And a 512 byte bucket of memory, if we say 512 divided by 1024, that's half a kilobyte. Do you think a half a kilobyte is a reasonable amount of space for each of our buckets of memory? Will that fit most of our little nuggets? You know, if we think about this being like a shoe bench, are most of our shoes somewhere between 0 and half a kilobyte in size? So it'll fit in those things. And if we think about, if we're storing ints, an int is 4 bytes. We're wasting, for each of those buckets, we're wasting 508 bytes of internal space. We have what's called internal fragmentation when you take the OS class, because we have a bucket of memory, we have a plot of land, and we've built this little tiny hut on it. Yeah, yet we have 11 acres, right? And we built an outhouse. That makes some sense? So these are more operating system decision things, not a right or wrong thing. Okay. So do we have a decent idea on how these tools are working now? All right, we're going to be building a char array. Well, we're going to be building up an array of strings is what we're really going to be doing. But if I look at this particular guy here, do I know how many tokens I'm going to have in there? Not yet. Hey, what am I going to need in order to come up with the number of tokens that are going to be in there? Well, I'm going to need to probably start processing this guy, and I'll have to add it to a collection capable of holding an arbitrary amount of elements. Do we happen to know how to create collections of things that hold arbitrary size things? Do we have an elastic list that we've been writing all semester, like a linked list? So we can create a linked list of strings and have it hold our individual pointers. One other thing I'll say here is we'll say string S6 is equal to S2 concatenated with S5. And then we'll print out S6. So does string concatenation work the same way as it did in Java? Yep. Or if we want to use the old school, we have a thing called string cat that will allow us to concatenate a source string onto a destination string, and it does the magic of lining up the memory addresses. All right, so in order to pull this off, we're going to start off by writing a linked list capable of holding a string, right? Because I'm going to want to store inside that linked list my 123 as a string. Then my plus sign as a string. Then my 13 as a string, then my minus as a string, then my 2 as a string. Then I can have it export that to an array for me if I'd like, because that linked list will now know how many elements are in it. Right? Go ahead.
That would just be a matter of changing terms in your linked list, right?
Yep. So we're going to update our linked list. I'll actually just write it new. It'll take less time. All right. So I'm going to go ahead and create a new file here. And we're going to create this a guy here called linked list. We just failed. You didn't fail. You ran out of time.
Yeah.
Why? What were you doing last night at 7:30? 8:30, 9:30.
Official business.
Because I kept checking. I was here till 11 last night.
I'll take the poll.
Go ahead.
Just a random question. Is there a built-in class for linked lists?
There is.
Okay.
Yeah, we're not allowed to use it
That's
yet.
fine. I was
There is. I think there's probably even a newer one, but there's definitely one in the standard template library called STL.
Is it vector?
Vector, I think, operates kind of like array lists did in Java. But similar thing. I think they're actually based on top of arrays. They're just expandable. But it's more fun to write our own thing, right? All right. And really, we're just going to be adding things to the end. So this is a pretty simple linked list. I don't need to build in all the extra things. I want to create a collection of stuff, and I just want to be able to tack something onto that collection, and for me to be able to update things later on, right? All right. So we're going to go ahead, and I'm going to include string.h, because I'm going to need to have some strings in this guy. And I'll have a class called, what did I call this guy? Linked list. And this guy will have a public and a private section. My public section is I want to point to the front of this guy, and my linked list is going to be a collection of, actually I don't need strings in here. I'll need nodes in here, right? So I'll go ahead and create a node class, node HPP. This guy is going to need to know about strings, so pound include string.h class node. Public, private. All right, and this guy is going to have a string payload, and then it's going to have a, I need to say using namespace, using standard. That.
Using namespace standard. Yeah.
There we go, Clancy.
Oh, this thing hasn't gone away yet. way to go, Clancy.
Come back.
Why are you undefined?
The strings we got like 50 years.
This might be a Visual Studio thing right now. We're going to let it cook for a little bit. All right, so he's going to take in a payload, and the payload type is going to be a string. And then we're going to also have a node pointer called next node. And we don't need previous nodes, right? And then we're going to go ahead and have a couple of methods. We want to be able to get the payload, because we're going to need that when we convert this guy to a array. So we're going to have a string get payload. You see, they color coded it here. That's interesting. Did I misspell something above there?
Do you need the string.h?
I shouldn't need string.h because it's in standard namespace. Oh, you know what? I think I need this. Yeah. So let me explain that. We're using the standard namespace, which actually lives in IOStream, and string lives inside of that standard namespace. The string we're using here. That's where he lives, inside of namespace standard. If I didn't say namespace standard here, I could say std like that and get to it.
I tried that and that did not, it still just gave me a problem.
I'd have to see your code because this is definitely the case.
Okay. Sounds good.
Yeah, unless maybe you did iostream.h or something.
No, I like did not have IOStream, and I just tried to see if I can like without using the namespace just call like std string.
Yeah, so string.h gives you a bunch of libraries for operating on strings.
Okay.
std namespace, which lives inside of IOStream, gives you the string class.
Okay, but calling like the std colon and then string without namespace, should that still work?
That should work.
'Cause that's what I did.
So if I did that and I said std colon
Okay, there's
std
probably some
colon,
problem on my
yeah,
end, but yeah. Okay, weird.
You still need IO string though.
correct, because
Okay, yeah.
the standard namespace lives in here.
Got it. Okay.
All right, so I'm going to have a node that's going to have a payload and the next node, and we're going to have the ability to get the payload, and we're also going to have the ability to get next node. And this is a node pointer. And we're going to go ahead and have the ability to set next node. This guy, I'll take in a node pointer. All right, so that is our node header file. I'll steal these things here and I'll go ahead and let's create our node C++ file. So we'll include node HPP and we'll go ahead and write these guys. All right, so get payload is going to return this payload. Get next node is going to return this next node. Set next node is going to set this next node equal to n. So that's what node will do. All right, so we've kind of built out our node, not too complex, just holds a couple pieces of information, but the type of thing, the type of payload it's going to hold is a string. Go back to our linked list here. So in our public section of our linked list, we're going to have to include node HPP, because this guy needs to know about nodes, right? So we're going to have a node pointer, maybe called head. And then we're probably also going to go ahead and keep track of a count. And then we're going to have a constructor for our linked list. And then we're going to have an add end. To our linked list. And this guy will return void. Okay? And notice we were able to use string here because we included node HPP, and node HPP has the namespace. Okay, so a linked list, we'll keep track of the front of it. We'll keep track of how many things we have in there. We'll have a constructor, and we'll have the ability to add to the end. We probably also want to have the ability to return a char array called maybe not a char array, a string array, maybe called toString array. We can return a pointer to the array. Because that's what pointers are. Pointers point to the base address of an array. All right, so we'll have a constructor, we'll be able to add something to the end of our list, and then at some point in time, we'll be able to ask our list to provide us a string array of all the elements in it. And that string array will have a length of size of string pointer, right? Okay, so let's go and write this part of it. So we need to do, I'll steal the stuff. Yeah, but I mean, it's just syntax. I mean, an array, a string array and a string pointer are the same thing. Actually, this guy is going to return an array of strings. A string pointer would point to the first element of a string. A string pointer would point to an array of strings. Because this is going to point to a collection of pointers. So this guy is a pointer to a collection of pointers where each of those pointers point to a string somewhere in memory that we're building up. All right, we'll draw a picture when we get to that point. It's the same thing as when we had the char pointer argv that pointed to a array of char pointers where a char pointer pointed to the beginning of the string. Since strings themselves are stored in memory and I'm pointing to the first string in the array, I actually can just say I'm pointing to a string pointer. This will be the base, this will be the string pointer that lives at the beginning of my array, and each of those string pointers will point to an actual string someplace else. So we could do it with a single pointer. Go ahead.
But, for example, like if that was a char, we would need char pointer.
Yes, but now I've locked myself into using, more than likely, using char pointers for strings instead of strings. Depends what the string class exposes to us. I doubt the string class lets us get at its underlying char array, even though I promise you strings are built on top of char arrays.
Okay, so but like hypothetically, if we wanted it to return basically the same thing, but with char arrays, we would just need a double pointer?
Yeah,
Okay,
because this
that
is
makes
a
sense.
pointer to a collection of char pointers.
Okay.
Where this guy is a pointer to a collection of strings.
Okay, that makes sense.
All right, so we will go and implement, do linked list CPP. I don't remember if I copied this. Let me go ahead and copy that. We also didn't write our constructor for node. Let me write that real quick. So that'll initialize a node for us. Go ahead.
Is polymorphism still a thing? Can you have a constructor that takes in two different?
Yep. Yep, polymorphism is a thing in every object-oriented language. Okay, so we'll go back to linked list CPP. And this guy will include linked list HPP. And we're going to go ahead and write these guys. Okay. So for our linked list, we'll set this head equal to null, and we'll set this count equal to 0. That's what a empty linked list is, right? If we're going to add to the end, we'll go ahead and say if not this head. That means if this is the empty list, we got to go ahead and create our node first. So we'll say node pointer n is equal to new node with our payload. So any way you cut it, we're going to be dealing with our nodes. Didn't I put node HPP in here? Oh, probably don't want my constructor to be private. We actually probably don't want any of these to be private, to be honest. I just basically wrote these backwards is what I did. I usually write the private section first and the public section, so we'll flip-flop that, put our fields in the private section and put our methods stuff in the public section. Things should be a little nicer now. For this guy, we'll flip-flop the sections. All right, so now I created my new node. If my list is currently the empty list, if that's the case, I'll go ahead and just say this head is equal to n. Else, if it's not the empty list, I need to make head, I need to have head point to this guy. So this head set next node to n. In either case, this count plus plus. So that's add end. So if I have the empty list, I add it to the end of the empty list. If I have the empty list, I just make the list the one list where head points to my new guy. Otherwise, I add it to whatever the end of the list is. So the thing after this is head. But now this is head is not necessarily the end of the list, is it? That's only the front of the list. This is actually add front. Probably don't want this guy add front. I want this guy to be add end, so I actually need to run to the end of the list. So I need a node pointer cur node is equal to this head. And then I'll say while cur node get next node. While that's a thing, cur node is equal to his own next node. Then I can say cur node set next node to n. Empty list, just make head point to it. Otherwise, get to the end of the list by starting at the beginning, keeping going until cur node no longer has a next node. Finally set cur node's next node equal to the new guy. This will always add to the end of my list. In either case, I have increased my count. For our special needs right here, we actually don't need to be able to remove stuff from our list. So we won't do that. I probably do want to be able to get something from my list. So let me go back into linked list here. Let's just say we'll do string get int index. And then we'll write this guy. All right, so we'll assume that index is a legal index. We could always, ask the question if it's less than 0 or if it's greater than count -1. It's not, but we'll go ahead and just create a node pointer. Cur node is equal to this head. For int I is equal to 0. I is less than index. I plus plus. Cur node is equal to cur node get next node. And then we'll return cur node get payload. We're not removing it from the list. We're just going to give them the string that lives at a particular index. Okay. Lastly, we can say we'll just write a display method real quick. Void display. All right, and the display method is going to run through and show all the things that are in the list. Display it to the screen. Let's see, linked list HPP uses node HPP, which has IO stream and the namespace, so we should be able to print all the stuff. So we'll go ahead and we'll say for int I is equal to 0, I is less than this count, I plus plus. We'll say cout this get I. Kick it down the line. So that should display all the things that are in there. All right. Let's go test our linked list now. We'll go back to driver. I'll include linked list HPP. We'll go ahead and create a linked list pointer. LL is equal to a new linked list. We'll say LL add end. Hello. World. LOL. Woot. Tell it to display itself. And there's my linked list of strings. All right, make sense? All right, so now I have a way I can have a collection of an arbitrary size collection of strings. So now what I want to do is I want to walk through every element of a, I wish I hadn't deleted that. Let's see, string, s is equal, what would I have, like 123 plus 42 minus 8 times 2. Let's just assume that, well, it doesn't matter. I want to be able to walk through this guy, and I want to add 123 to my list, and then a plus to my list, and a 42 to my list, and then a minus to my list, and an 8 to my list, and a time to my list, and a 2 to my list. I want all these things to keep getting tacked on to my list. All right, so I'm going to create another class. Call this whatever you want. I'm going to call it like string factory, something like that. So string factory, HPP. And this guy is going to include IO stream. Actually, we won't even need to include IO stream. What we'll do is we'll include link list HPP, which will come with all those other things, because I'm going to need to use my link list inside of here. All right, we'll have a class called string factory. This class will have a private section and a public section. We actually probably would make these static methods, but we'll talk about that eventually. But we're going to have a method in here called, what do I call it, split? Is that what we're supposed to write? Okay. So we'll have a method here called split, which returns a string pointer. And takes in as a parameter a string, as well as another string for delims. So I want to split this string on these delims. Does that make sense? That's what I want to accomplish here. So, for example, well, let's write the other part of this. So, actually, I'll just go ahead and give myself make that guy static. And I'll steal this, and actually this is not what you put in the header file. You put that in the header file. So I'll create my string factory CPP. Include string factory. String is ambiguous. Doesn't my string factory have? Why do I need to include? Oh, it's because inside here, oh, do I not have access to the namespace? Link list HPP is this guy. Node has it. Let me just get it to a good starting point for you guys. Using namespace. STD. And this is in string factory. Oh, I think what we're seeing here is split already exists. Split string. Is that not the case? Class. This is in CPP. I'm just finishing up this last second. Look, string, split string. So this is my HPP string factory. Oh, I just hadn't finished that thing. All right, so this is where we're going to walk through and give ourselves, and actually we can make this guy static now. We're going to walk through our string, looking for occurrences of these delimiters, building up a string, adding it to our linked list, and then having our linked list output for us a string array. Does that make sense? So that's the version of split we're going to write for Tuesday. I'm going to give you this as our starting point, and I'll put in main an example of calling our split function. Does the static need? Well, I'll give you how to call. I think I need to switch places on the static. I'll call the function from within main so you see how string factory works. And for right now, I'll just do a cout, write your code here or something like that. All right. So for Tuesday, implement your split function. If you already did it this exact way, you can just submit it. But otherwise, implement your split function in terms of a linked list of strings, ultimately producing a list, an array of tokens. Good.
Yeah, put a constructor on that one.
Well, we're going to need, we won't, if we have static methods, we won't need a constructor because we're just going to be calling the methods directly. But I'll look at that real quick and I'll give you what you need to use it. Sound good? Other questions? Go ahead.
Are we able to use those, like the char, like functions included in the string.h file on strings? Because I don't think we were able to do that.
Well, like which functions?
Like the string to token. I don't think you can use it on strings.
You can't. Oh, that's what you're asking. Can we use it on a string object? No, you can use it on char pointers.
Okay.
Yeah. And actually, if you look at string.h, it tells you what parameters it expects.
Mm-hmm.
So those functions, that all of them will say char pointers as expected inputs, not strings.
Okay.
Strings are not char pointers. All right, I will see everybody on Tuesday. Make sure you take a look at the Slack. I posted a thing that's downtown Milwaukee on Saturday, like a 9 a.m. to noon kind of meet and greet. It's called Code and Brew. You know, I think you can just even go and just work on your homework or something like that. You're supposed to bring a project and code, but it might be a good networking opportunity to meet people who might have internships and things like that around the community. So take a look at that. Also, we will have our midterm next Thursday. We'll talk about that on Tuesday. All right.